In another installment of our brief videos about finding slope from different forms, here we're looking for finding slopes from tables. And every graph that we have can be made into a table. Every table that we have can be made into a graph. So the methods we're using here, if you don't like the rise over run area of graphs, you can use our method right from making tables. So make tables from your graphs and use them to adjust. I made this from my nice little finger arrow right here, C-ROC. Remember, that stands for constant rate of change. So if you can find a constant rate of change, not just rate of change, but a constant one, we know we have our slope. And remember, if something is linear, then it has a slope, and if something is linear, then it also has a constant rate of change. So we just got to figure out how our information changes. Now we're going to look at series as a connection of x's and y's, but also look at x's independently and y's independently. So let's dive into some slopes from tables. In case you haven't heard, if you didn't watch my other videos, slope, remember, is that idea about rise over run. On a graph, when we did rise over run, we looked at 2 points on that graph and then rose and then ran to get to those two values and said that whatever values we rose and ran by would be our slope. So just by that quick little sketch there, if we go up 2 and over 1, our slope then is 2 over 1 because rise first, then run. So moving forward, as we kind of get through that, the bigger thing that's going to help us with tables is to think about it as change in y over change in x. Change in y, that's our rise, because when we're looking at a graph, however we go up looks at changes on our y axis. And if we go run, those are changes on our x-axis. So we see what these values are, and again, that looks to change in y over change in x. So if I'm looking at that and use that model to tables, what I really need to do is first off just figure out my change in y and my change in x. So I looked at my y's. Here I have a plus 5, plus 5, plus 5. So far I'm looking really solid. Before I can make my slope though, let's look at our change in x's to see and make sure that I have something constant. Plus 2, and plus 2. So I'm looking to see each step along the way how my information and my data changes. So since I have things that are constant, since all my 5s are the same number and all my 2s are the same number, I'm going to use this change in y over change in x to say a slope. So my change in y, we said every time or every step along the way we had a change in 5. For every change in 5 for my y's, I have a change in 2 for my slopes. Now if I want anything else to do is reduce, and I can't reduce this at all, so here's my final answer. My slope for this table is 5 over 2. In one final example, we're going to look to see what happens when we have growth that is constant but doesn't look constant. So again, we're looking at change in y over change in x, which is the same thing as rise over run. If we were to graph these pieces of data, we would have a point at 6, 18, because that 6 is my x and that y is the 18, so they kind of line up with those nice ordered pairs. So if you want to start thinking about these tables as just a series of ordered pairs, that might help you kind of thinking about rise and run or change in y and change in x. So looking at my changes in y's, remember we're looking at change in y over change in x. My first set of changes in y's go from 18 to 30, which to me looks like a change of 12. And then I go from 30 to 36, which is a plus 6, and then I look at a change of 3, plus 3. Now, since those aren't constant, I want to double check them on my x's and see if they do have constant growth rates. So let's look over here. I have a plus 4, a plus 2, and then a plus 1. So now I'm going to look at my ratios connected to each other. First off, in my change in y, change in x's, I have a growth of 12 over 4. And I'm asking myself, does that equal my next set of growth rates, 6 over 2? And that is also that equal my next set of growth rates, which are 3 over 1. All of those are equal to each other because I can multiply by 2 times 2, and I can multiply that again by 2 and again by 2. So I'm just proving that those are equal to each other and equivalent. When you know that all three of those ratios are equal or equivalent, again, you know that this graph is, or that this table is linear, and you know it has a constant rate of change because we're seeing those, and these two are connected to each other. If it's linear, it has to have a constant rate of change. And we're seeing those because it all boils down to for every 3 y's, I go up 1 x. So I can use any single one of these as my slope. However, I should use this one because it is reduced. That means my slope now is 3 over 1. The last thing that we look at connection to, now this is a lot of sloppiness, so I'm just going to recreate this graph. Or this table, I'm sorry. The last thing I could look at, and this is to determine proportionality, is to look for those constant multipliers in between my x's and y's. every step along the way here, I have a multiplied by 3 relationship happening between my x's and y's. That shows me that we're proportional. And we can also use that to kind of find if it's proportional, that can help us with our constant rate of change. Because that tells us at 1x, I'm going to have 3y. At 0x, I'll have 0y. At 2x, I'll have 6y, because everything there has to be that times 3. And so if we can see that and track that all the way through, if we can prove they're proportional, that multiplier helps us turn into a slope, because now I'm seeing that every 3 y's is going to be 1x. So my change in y over my change in x is the same thing as this 3 over 1. So again, we're looking for proportionality and linearity through tables, and we're going to connect those tables through graphs. Again, we're just looking for those basic constant rates of change and proving that things are linear in order to find a slope. Once you know it's linear, you've got to figure out a slope using those change in y, change in x.